So, physics sports. What is physics? Physics is concerned with the very small and the very, very large. And so when we look at this, we have to use scientific notation. So we'll practice scientific notation type thing. These little dots that you see here are actually atoms, and these are the energized little atoms on the gold surface. Okay. And this is a spiral galaxy that is light years across, which it means that's how far light travels across it. Like if something's 500 light years, it'll take light 500 years to get across this thing. All right, it's taken the light from the Big Bang to reach us. That from that first singularity, the light from that, it's taken 13.7 billion years for us to see. So when you're looking at the stars, when you're looking at the eclipse, actually, if the moon is 250,000 miles away, so there was actually probably a delay there of about probably a thousandth of a second. That's what was going on. When you actually go all the way out to the sun, or maybe a tenth of a second, when you go all the way out to the sun, the light we receive from the sun is 8 minutes old. All right, so when you look at the sun, it's already aged another 8 minutes. And the gold surface on the dots are nanometers. Now then, let's use this. Let's write some numbers, shall we? All right, and I'll show you something here, and then we'll in this little part of the lesson. All right, let's look at scientific notation real quick. All right, so this is one of the things that I use. I use this little ladybug device here, and it will pop up. I've got it all plugged in, and it should be in focus. It's a little reading lamp thing. Probably got too much stuff on for it to, and then I make this bigger. So this is our notes for mini lesson 1. And what I'll do is what I do with these notes is I put them in, I run them off, make a PDF file of them, and also post them as a file. Okay? So, scientific notation, those one measurements were in nanometers. Okay? An electron from a proton in a hydrogen atom averages about 0.01, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15 meters from the center of the proton. Okay, that's its orbit. That's its orbit. Right, and this would be in scientific notation. In scientific notation, we would say this is equal to, we'd bring this over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So it's 1.5 times 10 to the negative 11 meters. All right? Or, we'd also do it in nanometers. I don't want to get into all that. But anyway, so that's scientific notation. Now, also, this is 1.5 times 10 to the negative 11 meters, and those are 1, 2 digits here. So this is, the significant figures is 2. All right. If it was 1.89 or something like that, this is 3 sig figs. And I'm not going to gig you too hard on this at all, but I just kind of wanted you to keep your numbers in 2 sig figs because that's the way I enter when you have to do a calculation on Blackboard. And the 2 sig figs of this would be, well, 9 is bigger than 5 in this, where this is. And so that would be 1.9 in 2 sig figs. So this is the scientific notation, and this is the significant figures. Okay? All right. So the sun is 93 million miles away. Sun is 93 million miles away. So in scientific notation, that would be 93, and then we'd put a million. 1, 2, 3, 4, 5, 6. Multiply that by a million. In scientific notation, in 2 sig figs, that would be 9.3 times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the positive 7 because we went to the, notice the decimal is here and we'd go this way. When we go to the left, we make it positive 7 miles. And one of your homework, and when you entered scientific notation on Blackboard, I've never taught this before to my physics sport class, by the way. When you, scientific notation on Blackboard, this would be 9.3 big E positive 7. This, by the way, get used to it. This is the way I do sevens. Okay, good place to take a break.